yeah, what we will present here, so the colleagues here, Lalitha Abhaya, she is here an expert in the MBSE field, in the method and tools department, and heavily supporting us. And Dominique Ernadote, also colleague here from the systems architecture departments, and also a real expert on the on these topics. So we gathered around in order to explain this kind of difficult thing, why in this project FCAS we want to use two MBSE frameworks at the same time. So what is it good for? But before we go, so we should first of all once more, what is Airbus? What is the FCAS project in Airbus? Then we will switch over to describe a little bit the problem domain, why in this huge systems of systems program we decided to go for several, the appliance of several architecture framework approaches. And we will present therefore, of course, the UAF, but the Airbus architecture framework called MOFLT, and then finally come to the solution, or present the solution approach of how to take here best practices or best breed approach from both and make it happen inside the tool set. So maybe, and of course, finally we come to the conclusion and outlook. So first of all, maybe we can do it short. I hope most people know Airbus. We are producing mainly commercial aircraft, and probably some of you or most have already used the one or other product we are producing, but maybe it's not so well known that also we are in the field. We have two other divisions producing helicopters, where, by the way, we are also in the civil market, world market leader, and we are in the defense and space sector. This is the second division where Lalitha, Dominique, and me, we come from. And then maybe we can go to the next slide. Now, now the question is, what is this strange animal FCAS? FCAS stands for Future Combat Air System, and it's about, of course, a sixth generation fighter aircraft to develop. But it's more than that. It is also to develop several drones that will be connected to this new generation fighter, and the connection shall be established by something that we call the combat cloud. We have several more pillars here about, of course, a next generation engine to equip the drones and the fighter, as well specific pillars for sensors and low observability technologies. And you see the huge variety of companies involved here with our main partners, Dassault Aviation in Indra, but much more European partner, which itself gives, of course, the project a certain complexity already. However, it is required to serve this huge ambition of here the European core countries, Spain, France, and Germany, to develop this kind of new aircraft defense system. And I put this picture there on some of this kind of approaches we are taking that show a little bit the scope in terms, by the way, it's not just a new generation fighter and remote carrier. Through the combat cloud, we also want to connect existing assets of the European air forces like Eurofighter, Rafale, Eurodrone, MRTT, and even beyond. And when we go in showing this kind of approach with FCAS, I think the most interesting part of it is that the singular performance of the or behaviors of the artifacts involved is not in the focus of our advertising or publications, communications, but it's more the behavior of all artifacts of all systems together in the systems of systems approach that will make the huge difference and is one of the biggest challenge of our FCAS program. And I would say it's the systems of system project, at least at Europe, currently running. And of course puts our capabilities for model-based systems engineering clearly in a center, in a focus. Maybe in the next slide just wanted to give one highlight about the enablement for such kind of program required, which as you have seen all the companies involved. So in order to make this complex development happening, it does not work anymore that we're sending per email some kind of files around. What we really require here clearly is what we call the common working environment. So some kind of cloud-based environment accessible from all program partners so that they can collaboratively work on the elaboration of the deliverables of the development and the design and so on. This kind of working environment is a pillar, now an item and a delivery item beside the fighter and the remote carriers and the combat cloud itself. And they shall allow this kind of new way of working. And the focus we see, of course, a classical PLM environment, of course, also a strong MBSE environment here with Cameo and doors. We will have advanced software development environment to enable a CI/CD pipeline and collaboration features. Just give you an overview that, of course, the enablement of tools and method is key to make this ambitious undertaking working. With giving you this overview, I would then hand over to my colleague Dominique for the next slide.
Thank you, Jörg. Jörg explained really clearly the complexity of the context. So we have a system of system to design, which is by essence very complex and composed of complex systems. And as you see also, the organization is rich and a lot of companies are involved which have to interact each other in different countries with different national security concerns to be addressed. So in this specific project, we have the system of system level to be addressed, and this is exactly what UF bring us. And the similar framework developed by the different Ministry of Defense, so NAF, MODAF, and DODAF, had this objective in mind when they designed the framework. So to be a support for capability acquisition entities. So, for example, the NATO. This is the concern, and keeping this concern in mind, we need all the notion and the concept offered by the UAF, which is approved by the NATO. In this concern, we have things demonstrating this morning, for example, the capability roadmaps, identification of gaps, demonstrate how the system will be incrementally supporting the needs in the next 20 years, for example. So this is really at the strategic level, also modeling the different resources as gray boxes, should I say. It's not so black boxes, but not going into all the details. So yes, we have to do that, and also the customers, so NATO, different MODs are requesting models which are UF compatible, so NATO compatible, so to be reviewed by the stakeholders. So this is relevant for us, but we have also to go into the details and to address the physical aspect, so the structural, the electrical, thermal aspect of the different system composing the system of system. And this is where we need to make a bridge between this capability vision and these very technical details, including simulations, verification with benchmark, and so on. These two aspects have to be considered, and a second one is the multiplicity of companies, as we explained just before. So we have also to be able to exchange with different companies coming with their own method and tools and frameworks. So this is why Airbus developed a complementary framework, which is named MOFLT, which stands for Mission, Operation, Function, Logical, and Technical. So it addresses 5 layers, really at the technical level. Keeping in mind that we have both these two frameworks, we also have to demonstrate the global consistency between the different models. So what has been decided is to use the UAF and then the NAV compatible framework at what we call the level 0. So we match the system of system concern. So at this level, we are talking, we have in fact a different L0, should I say, because the FCAS itself, it's a system of system of system. If we consider inside the next generation weapon system, it is itself a system of system. So we have different topics to be addressed, and the combat cloud allowing communication between the different components. It's also a specific purpose. So the FCAS, it's a very, very big system of system. And for this level, we are using the UAF, including capability description and so on. For the level L1, L2, and this is where we start also to speak with the suppliers. We are using the Airbus specific framework and try to provide some standardized exports, so to ensure communication with equipment suppliers, for example, and also to support 3D analysis, simulation, and so on in a specific tool. I guess this is next slide again about the detail on the MBSE framework developed by Airbus. So you see here the different layers, so mission, operation, functional, logical, and technical. Just to keep in mind that okay, at the level 0, we have also some capability description, operational description, and technical description, which remains at level 0. And when we hand over to the different level 1, we have also to repeat this type of layer, so including for each level 1, the missions, operational architecture, and so on. So it seems to be similar framework, but the details are not exactly addressed at the same level. But obviously, we need for each levels to keep this global consistency. I don't know, Jörg, if you want, I launched the video, which is behind this image.
Did not start. Maybe we can also do without. Normally it should maybe.
See, this is possible. I can click on it. Just.
Yeah, but we don't need it. Maybe.
Okay, I will skip. If we have rooms, I will go. So the framework developed by Airbus is also composed of different parts, including a method which is tool and language agnostic. So a method just describes the different steps we have to perform when we, for example, we want to describe the missions, operational architecture, and so on. There are some handbooks which are more tool-oriented, so mainly based on the camel modeling tool and language such as XML. And we have some plugins to ease tedious activities or tasks and to improve the ergonomics aspect. We also provide some examples and trainings. Just consider we have several hundreds colleagues to train on this specific framework. I will maybe hand over to Lalitha for this part, which is explaining how we use the NAF in the specific context of FCAS project.
Dominique, you are going to share, or do you want that I share?
I will continue to share, so I think it's simpler.
Okay. So, yeah, Dominique and Jörg explained, so we are using this combined approach. So I am not going to talk about it again. I think Jörg also said that we have this client requirement. Sometimes we need to deliver in NAF v 3.1 format or NAF. There are discussion of also about NAF 4, mainly NAF 3 views should be included in deliverables according to the contracts. So we tailored because of these two versions of NAF, we decided to model in UAF. So not every views are created. So we wanted to tailor the framework and provide the methodology. You may see that this UBM methodology is published in INCOSI IS 2021. So I present just a summary of this in this slide. So it gives the step-by-step method to create a selected set of views. As you can see, it is really the essential views according to the objectives. Dominique already said that we use it to model mainly this mission, enterprise mission and operational part of the architecture, and of course mainly focused on system level. And then we handing over to the other projects which develops architectures of different product systems as remote carriers or fighter. Yeah. So you can go to the next slide. I will not detail this slide maybe. So here you can see how this transition is done from two kind of models. We have this at L0 level UBM model. Mainly we develop enterprise architecture, mission, operational, and as well as we have also some L1 systems which are I can say it, I think, Combat Cloud, which is mainly service-based. So we have services and also logical and physical layers, which are model used in UBM. UBM, when I talk UBM, it means UAF-based MBSE methodology. So mainly create UAF views and use a UAF profile or domain model. So you can see here, normally we have these links. For example, in Moffat, there are functions. So these functions, we have links to operational activities as function enables those operational activities, as well as we have the links to services as functions invoke services. So between two models, we propose these traceability links. It means each L1 model uses L0 model developed in using UBM. And then we provide the traceability between two models. For example, in UBM L0, we have high-level functions, which are then decomposed in MOFLT as L1 functions. Same as logical, and here we call it in UBM physical layer, but in MOFLT technical layer. Sorry, someone want to say something? It's okay, you can, next slide. So here I put in details, some details on traceability between UBM model elements and MBSE framework elements, which when we call MBSE framework, MOFLT, it is same, MOFLT. So you see again, I don't know if I have enough time. So functions, you can see these functions in L1 MOFLT. There is a link to enables operational activity defined in UBM, L0 UBM. You see also functional decomposition link, as well as I already said, function invocation of service functions. So this is the same little bit in details what I presented in the previous slide. Next slide, Dominique. So these are the examples of realization of these what I presented in models. So we have traceability matrices between two kind of models. It means you can see here MOFLT model elements, and also you are familiar that uaf-L0 functions, for example. This present the traceability. Yeah, one example. There is another example where MOFLT OTR elements. OTR means operational task realizations to the operational activities defined in UBM. Okay, I think this is what I wanted to present. Dominique.
Yeah. Maybe first of all, yeah, I take over. I, by the way, followed also your questions already in the chat, and clearly there were questions on why we distinguish now between logical and technical elements in the MOFLT, and the thing is that in the logical layer we can still be a little bit more abstract, simply saying, so what signal, what message we really use, and then in the technical layer, for example, which bus, which hardware item now is used to convey this kind of signal or message. It brings really value add to have this distinction. And of course, then the technical layer then is really also connected to physical simulation, and makes also the link then into the technical design in the 3DX experience platform, where then we develop out of the technical layer really the physical breakdown of the product and the and also, for example, electrical design. So it's really, we take advantage of the of linking now the Cameo with our MOFLT MBSE framework, and the underlying data model called SECAM, Systems Engineering Common Architecture Model. This is the underlying meta model together. And here I just wanted to give some kind of so the idea is that we of course need to also think in extended enterprise, and in our collaborative projects here, especially with Dassault Aviation, which is A, the Eurodrone, and B, the NGF, we are using this kind of now meta model for the interoperability. And this was agreed in a project called Eureka, which stands for European Ecosystem for Aerospace. Maybe I hand over to Dominique for the last conclusions.
5 minutes left.
Yes, okay. And this is the last one. So the conclusion is in very big projects such as FCAS, defining system of system for the future, we have to face two realities: the complexity of the system itself, but also the multiple contributors and customer with coming with their own requirements. So compatibility with the standard for some models, and align with best practices between the different partners. So each of them is coming with their own method, and the Eureka project we just explained before is an initiative to harmonize and to try to find some consensus on the common best practices. So this is additional difficulties, and also to provide some specific environment to work. So we have in this context a requirement to provide models in UAF, and this is really a good point for us because we have also this capability acquisition to analyze. And we demonstrated that we need also to complement with other specific framework to address the more technical aspects. So the reality of the big project is that we have to use multiple framework. And today, this is technically possible. We have demonstrated that. Having the CSML foundation as a common part for UAF and MOFLT really helps. So we can use a unique tool, for example, to do that, or at least to exchange between different tools if we are XMI compatible. This combination is not just two framework put aside, but we need to ensure traceability between the different levels we are modeling with each framework to ensure the global consistency of the project. Specific attention has to be paid on the usage of different frameworks. Is that we will have different communities, and obviously at the boundary of these communities, there are people needing to talk both languages. So it's some extra work for them, and so we have to think about the ability to present, for example, UAF model in a MOFLT flavor, or the opposite, or the opposite. And this is something we have done also, which allows the handover with less difficulties. This is what we call the transparent translation between the two frameworks. And I will maybe give you the chance to raise one question.
So I think we have already one question here from Piotr Malecki. I see on if all customers agree to use Magic Draw for UBM MFLT. And the point is, at least on the customer side, they like the Bayern BW from Germany or the DGA from France. They use their specific tools, like the HOPEX tool, I think on the DGA, and the Enterprise Architect at the Bayern BW, so here the German customer side. And this is why, as Lalitha has explained, deliver the data in NAF format, and the toolset that has been developed here from Airbus Defence and Space allows the conversion of the UBM model, the UAF model, into enough that in the data format of enterprise architecture and HOPEX, so that we can deliver our deliverables in the format the customer expects. For the work in the with our partners, of course, we are requesting either to use the same toolset or being able to convert their data. For example, if some of our partners like Thales would like in their back office to continue to work with Capella Arcadia to convert their functional or logical architecture views into the MOFLT standard, and thereby enrich our central architecture model inside our common working environment. I hope this answers this question.